In this Fabsec tutorial video, we will show you how to model and design a composite cellular beam in FBEAM. The first step in the process is to create a new project. This is done by selecting the New Beam option on the top ribbon and then assigning the appropriate design code. Next, the wizard prompts the user to select their desired beam type. There are a number of options here, from non-composite to composite cellular. Depending on your license, there is also an option to design the beam in the fire condition. In this instance, we will select composite cellular. Now, it is time to start filling in the beam properties. The first property to assign is the beam span. In this property, the user has the opportunity to change the span conditions and assign a precamber if required. Next, the user will input the initial section geometry. For this example, we will choose a 500 mm deep beam with 200 mm wide flanges. The floor property is where the user should add all of the relevant slab information, such as floor type, slab depth, concrete grade, etc. In this example, we have selected custom cells, so we will need to assign the cells manually. As you can see, this option gives a high level of freedom for the user to specify and position various cell types. The layout property lets you specify whether the beam is an internal beam or an edge beam. The user can also specify the span direction of the slab, the distance to adjacent supporting members, the location of any incoming secondary beams, and the restraint conditions. The load combination set will appear as appropriate for the beam type selected. In this instance, we can see that the software has defaulted to construction, composite and SLS combinations. The user is now prompted to specify floor loadings. By default, the software assigns a standard office load set. For beams subjected to additional loads, the software provides the user with the opportunity to specify additional point loads, distributed loads, moments, and axial forces. The user is able to specify studs as appropriate. By default, the software will position studs in the troughs of a previously selected metal deck profile. Finally, the user can tweak analysis settings, such as serviceability limits and shear connection standards as required. Now that the beam wizard has been completed, the user can review the design unity factors to examine the critical design checks. The user can also verify the analysis results to ensure that the desired load has been added and applied correctly. Review the 3D model to check span conditions and cell geometry. Select individual properties and adjust as necessary. Once the user is happy with the design, there are a number of report options available. The project schedule provides a summary of the beams in a project. This can be helpful when reviewing large projects. Finally, the long report gives a more detailed look into the analysis results and design checks for each load combination. Thank you for watching this Fabsec tutorial video.